Dr. Jeffrey Hamilton had 40 years studying human evolution, taught at Oxford University, published extensively on early hominid migration, and was considered one of the world's leading paleoanthropologists when he received a paper submitted to the Journal of Human Evolution from Dr. Armand Miyares, a Filipino archaeologist at the University of the Philippines, claiming discovery of a previously unknown human species in Callao Cave, Luzon. Jeffrey read it with growing irritation. The paper proposed that fossilized bones found in the cave, a toe bone, teeth, and hand bones, represented a distinct species of early human that had lived in the Philippines 67,000 years ago. Jeffrey wrote his peer review with barely concealed condescension, while Dr. Miyares' enthusiasm is commendable. The proposed new species is almost certainly misidentification of Homo sapiens remains. The Philippines is an island archipelago that was never connected to mainland Asia during periods when early hominids migrated. The water barriers would have been impossible for early humans to cross. The presence of a distinct human species in the Philippines is therefore impossible based on known migration patterns. I recommend rejection, he called his colleague at Cambridge. I've just reviewed the most absurd paper, some Filipino archaeologists claiming he's found a new human species in a Philippine cave, as if early hominids could have crossed ocean barriers to reach islands. It's amateur work, really. What Jeffrey didn't know was that Dr. Armand Miyares had spent 15 years excavating Callao Cave, working with minimal funding, basic equipment, and constant skepticism from Western scientists who assumed Philippine archaeology couldn't contribute meaningfully to human evolution studies. Armand had discovered the bones in 2007, a toe bone with curvature suggesting both bipedal walking and tree climbing, teeth with unique characteristics, hand bones showing distinctive features unlike any known human species. He'd spent years documenting the find, conducting multiple dating analyses, consulting with specialists worldwide, building an ironclad case before submitting to publication. The rejection from Jeffrey and other Western reviewers was devastating, but not surprising. Armand had faced this his entire career, the assumption that significant archaeological discoveries only happened in Africa, Europe, or mainland Asia, never in the Philippines. The scientific establishment had a mental map of human evolution that didn't include Southeast Asian islands. But Armand knew his evidence was solid. He continued his work, expanding excavations, finding more bones, gathering more data. He collaborated with French, Australian, and American researchers who were more open-minded, building an international team while Jeffrey and others dismissed him. 7 years later, in 2019, Armand's team published their findings in Nature, one of the world's most prestigious scientific journals. The paper presented overwhelming evidence for a new species, Homo Luzonensis. The bones showed a unique combination of primitive and modern features never seen before. The dating was confirmed through multiple independent methods, 67,000 years old, contemporaneous with modern humans but distinctly different. The discovery was revolutionary, proved that human evolution in Southeast Asia was far more complex than Western scientists had believed, that multiple human species had existed simultaneously across the region, and that early humans had indeed crossed ocean barriers, reaching islands previously thought inaccessible. The scientific world erupted. Headlines worldwide announced the discovery. Museums rushed to update their human evolution exhibits. Textbooks had to be revised, and Jeffrey Hamilton, who'd dismissed Armand's work as amateur, found himself professionally embarrassed. His peer review rejecting the initial paper was leaked online, becoming a case study in Western scientific bias. At an international paleoanthropology conference, 6 months after publication, Armand presented his findings to a packed auditorium. Jeffrey was in the audience, having flown to the Philippines for the conference, feeling obligated to see the evidence he'd dismissed firsthand. Armand's presentation was meticulous, showing every piece of evidence, the fossil bones, the dating results, the comparative analysis with other hominid species, the geological context of the cave, the evidence of tool use, the implications for human migration theories. When he finished, the applause was thunderous. During the Q&A session, Jeffrey stood. The room fell quiet. Everyone knew his history with this discovery. Dr. Miyares, Jeffrey began, his voice tight, I owe you a public apology. I reviewed your initial paper submission and recommended rejection. I said your proposed discovery was impossible because the Philippines was isolated by water barriers. I called your work amateur. I was completely, catastrophically wrong. He continued, his professional pride warring with scientific integrity. I allowed my preconceptions about where important discoveries happened to blind me to solid evidence. I assumed Philippine archaeology couldn't contribute meaningfully to human evolution. That was bias, pure and simple. Your work has fundamentally changed our understanding of human evolution in Southeast Asia. Homo Luzonensis rewrites migration theories, challenges our assumptions about early human capabilities, and proves that the Philippines was far more significant in human history than Western science acknowledged. I'm sorry I tried to prevent this discovery from being published. The room was silent. Then Armand spoke, his voice gentle. Dr. Hamilton, I appreciate your apology, but this isn't about you or me. It's about how science works. For too long, Western scientists decided what was possible based on their experience in Europe and Africa. Southeast Asia was assumed to be peripheral to human evolution. The Philippines especially, we were told we were too isolated, too remote, too scientifically unsophisticated to contribute major discoveries. But human evolution didn't follow Western assumptions. It was messier, more complex, more widespread than anyone thought. He continued, Homo Luzonensis proves that early humans were capable of amazing things, crossing open ocean, adapting to island environments, evolving unique characteristics. But we almost didn't discover it because the scientific establishment assumed. Filipino archaeologists working with limited resources in a peripheral location couldn't possibly find something important. How many other discoveries have we missed because we only look where we expect to find things? How many Filipino, Indonesian, Malaysian scientists have evidence that Western journals won't publish because it doesn't fit established theories? The conference marked a turning point. Major funding agencies began investing in Southeast Asian archaeology. Western universities established partnerships with Philippine institutions. The University of the Philippines, where Armand taught, received grants for archaeological research. But more importantly, the discovery validated Filipino scientists working in fields where they'd been systematically dismissed. Students in the Philippines studying archaeology, paleontology, and evolutionary biology could now point to Homo Luzonensis and say, "We made one of the most important human evolution discoveries of the century. We belong in this science." Jeffrey returned to Oxford, changed. He began teaching a course on scientific bias, using his own dismissal of Armand's work as the primary case study. I had 40 years of experience and every professional credential, he'd tell students. Dr. Miras had less funding, less prestigious institutional backing, and was working in a location I'd mentally written off as scientifically peripheral. But he was right and I was wrong because he had evidence and I had assumptions. That's the lesson: evidence trumps assumptions, always. And assumptions about who can make important discoveries, where discoveries can happen, and which scientists we should take seriously, are often the most dangerous biases in science. 5 years after publication, Armand was invited to deliver the keynote lecture at the Royal Society in London, one of the world's oldest and most prestigious scientific institutions. Standing in the same hall where Darwin's work had been presented, Armand spoke about Homo Luzonensis, but also about something bigger. This discovery happened because Filipino scientists didn't accept being told we were peripheral to human evolution. We excavated our own caves, studied our own fossils, and trusted our own evidence even when Western experts said we were wrong. Homo Luzonensis is important not just for what it tells us about human evolution, but for what it tells us about who gets to participate in science. He concluded, "Science is supposed to be universal evidence-based, open to discovery from anywhere, tested through peer review. But in practice, science has often been dominated by Western institutions that decided what was possible and who was credible. Homo Luzonensis couldn't exist according to Western migration models, so Western reviewers rejected it without examining the evidence. But it did exist, and we found it. And now every human evolution textbook has to include the Philippines, not as a footnote, as a major chapter. That's not just a scientific victory. That's a victory for every researcher in every country told their work doesn't matter because they're not at Oxford or Harvard. Today, Callao Cave is protected as a national cultural treasure. The site, where Homo Luzonensis was found, attracts researchers worldwide. Armand's team continues excavating, finding more evidence that the Philippines was home to multiple human species over hundreds of thousands of years. And Jeffrey, who tried to prevent the discovery from being published, now cites Armand's work in every lecture he gives, always including the story of how he rejected the paper and what that taught him about scientific bias. In his Oxford office, Jeffrey keeps a replica of the Homo Luzonensis toe bone on his desk with a plaque below, to remind me that the most important scientific discoveries sometimes come from the places and people we least expect. That dismissing evidence because it contradicts our assumptions isn't scientific skepticism, it's arrogance. The Filipino archaeologist I called amateur just rewrote human evolution. The question I ask my students now: what other discoveries are we missing because we're still looking in the wrong places and dismissing the wrong people? The British archaeologist who mocked the Filipino discovery now teaches that Western science's greatest blind spot isn't lack of technology or methodology, it's the assumption that important discoveries only happen where Western scientists expect them, done by people with Western credentials, in locations Western academia considers scientifically significant, and a toe bone from a Philippine cave, dismissed as impossible by experts who never bothered to examine it closely, now sits in museums worldwide, proving that human evolution was shaped in places those experts had written off as too remote, too isolated, and too scientifically unsophisticated to matter. What Isabel didn't understand was that piña fabric, specifically the finest quality piña cedar from Aklan, represented one of the most technically sophisticated textile traditions in the world. Maria Santos came from a family that had been weaving piña for 6 generations. The process began with extracting fibers from pineapple leaves through a meticulous process called pagkikiskis, separating individual strands thinner than human hair. These fibers were then knotted end-to-end by hand. A master weaver could identify the optimal knot placement to create fabric that was both translucent and strong. The weaving itself used traditional wooden hand looms, where every thread was manually controlled, allowing patterns of extraordinary intricacy that mechanical looms couldn't replicate. A single meter of fine piña cedar could take 3 months to complete. The fabric was naturally lustrous, breathable, and stronger than many synthetic materials despite its delicate appearance. But more importantly, the finest piña had a quality that modern textiles couldn't achieve, seemed to glow with an inner light. The natural fiber structure refracting light in ways that synthetic fabrics couldn't duplicate. Spanish colonizers had called it cloth of gold for how it shimmered in candlelight, but to Isabel, it was just rustic craftwork, unsophisticated compared to French textile technology. The competition proceeded without Maria's piña submission. Isabel selected winners who used innovative synthetic blends, smart fabrics with embedded technology, and bioengineered materials. The international fashion press covered the awards, celebrating the future of haute couture textiles. Maria, in her small workshop in Calibo, Aklan, read about the competition results on her phone and felt the familiar disappointment. She'd hoped that international recognition might help preserve piña weaving. Younger generations were abandoning the craft, unable to earn living wages, the knowledge dying with elderly master weavers. But then something unexpected happened. A Filipino-American fashion entrepreneur named Sofia Reyes, who'd been following the competition, reached out to Maria directly. Sofia had an ambitious idea: showcase piña fabric, not in a competition judged by European designers, but on the runway at Paris Fashion Week itself. Maria, I've secured a spot at Fashion Week for an emerging heritage textiles showcase. I want to feature your piña, but not as ethnic costume, as haute couture. Can you create pieces that would compete with any Paris fashion house? Maria was terrified and exhilarated. Creating couture pieces in quantities and timeframes Fashion Week required would be nearly impossible. But she agreed. For the next 6 months, Maria worked with every master weaver in Aklan she could find. They created piña pieces that showcased everything the fabric could do: evening gowns that seemed to float like mist, cocktail dresses with geometric patterns achieved through resist dyeing and weave variations, a wedding gown with embroidery so fine it looked like frost on silk. They used traditional techniques, but pushed them to extremes, creating effects that demonstrated piña's unique properties. The translucency allowed layering effects impossible with opaque fabrics. The natural luster created depth without artificial shine. The hand-woven texture gave each piece unique character while maintaining structural integrity. Paris Fashion Week arrived. Sofia's showcase was scheduled for a smaller venue. Emerging designers didn't get the main runways, but word had spread about the Filipino textiles, and the audience included several major fashion editors, buyers, and unexpectedly, Isabel Moreau, who'd heard about the Philippine Fabric Showcase and came out of curiosity to see what traditional weaving looked like when someone tried to pass it as haute couture. She expected to be politely dismissive, maybe even write a critique about respecting indigenous crafts without pretending they belonged in serious fashion. The lights dimmed. The first model emerged wearing a Pina evening gown in natural cream. The audience gasped audibly. Under the runway lights, the fabric seemed to emit its own luminescence, the natural fiber structure creating an ethereal glow. The transparency with strategic layers created modesty while showcasing the technical achievement of weaving fabric you could see through without it being fragile. Isabel leaned forward, her trained eye-catching details she couldn't believe. "That's hand-woven," she whispered to her assistant. "That consistency, that quality impossible by hand." The second piece emerged a cocktail dress with geometric patterns in natural dyes. What stopped Isabel cold was recognizing that the pattern wasn't printed or woven with colored threads. It was created through resist dyeing techniques that required planning the entire design before weaving began, then executing it with such precision that the pattern aligned perfectly when the fabric came off the loom. That level of planning and execution exceeded what most modern textile designers could achieve with computer assistance. The third piece was a wedding gown that caused Isabel to stand up from her seat involuntarily. The Pina fabric was embroidered with thread made from the same pineapple fiber, creating raised patterns that seemed to be part of the fabric itself. The embroidery technique called collado involved removing threads from the woven fabric and embroidering around the gaps to create lace-like patterns, essentially reweaving sections of the finished fabric to create three-dimensional effects. When the showcase ended, Isabel didn't return to her seat. She went backstage, something she rarely did for emerging designers. "I need to speak to whoever created these textiles," she told Sofia with uncharacteristic urgency. Sofia brought Maria forward, still wearing her simple clothes, looking uncomfortable in the high-fashion environment. Isabel, who never apologized and rarely showed uncertainty, hesitated before speaking. "Madame Santos, I owe you a profound apology. I rejected your textile submission to the competition. I called Pina fabric unsophisticated, said it lacked technical complexity for serious fashion. I was not just wrong, I was ignorantly dismissive of what I can now see as one of the most technically sophisticated textile traditions I've ever encountered." She gestured to the garments, the fiber preparation, the hand knotting to create continuous thread, the weaving precision, the pattern planning, the natural luster, the translucency control, the embroidery integration. This represents mastery that modern fashion has lost. We use machines to achieve consistency because we've forgotten how to achieve it by hand. We use chemical treatments to create effects you achieve through understanding of natural fiber properties. We use computers to plan patterns you carry in generational knowledge. This isn't unsophisticated. This is sophistication I didn't recognize because I was measuring it against the wrong standards. Maria spoke quietly, her English heavily accented. "Madame Moreau, Pina weaving is dying. Young people leave because hand weaving cannot compete with factory textiles on price. We cannot make living. The old weavers, they die, the knowledge dies with them. I came to competition hoping recognition would help save the craft. When you rejected it, I thought maybe our tradition is truly outdated, truly unsophisticated like you said." Isabel felt genuine shame, a rare emotion in her experience. "Madame Santos, if I could undo that rejection, I would, but perhaps I can do something better. I would like to collaborate with you. My fashion house will commission Pina pieces for our next haute couture collection. We will pay what the work deserves, not craft prices, but couture prices. And we will tell the world where this fabric comes from and why it represents textile mastery that Paris should learn from, not dismiss." The collaboration transformed both their careers. Isabel's next collection, featuring Pina prominently, was celebrated as revolutionary. Returning to artisanal roots while pushing technical boundaries, fashion magazines that had never mentioned Philippine textiles suddenly published features on Pina weaving. Orders came from haute couture houses across Europe. But more importantly, the prices paid for genuine masterwoven Pina finally made it economically viable. Young Filipinos began returning to learn the craft, seeing it not as dying tradition but as valuable skill. Weaving schools opened in Aklan, teaching traditional techniques to new generations. 3 years later, Isabel invited Maria to Paris, not as a supplier but as a collaborator, being honored at the Chambre Syndicale de la Haute Couture, the governing body of French haute couture for contributions to textile arts. Standing before the same fashion establishment that had dismissed Philippine weaving as unsophisticated, Maria presented on Piga's technical properties and cultural significance. Isabel introduced her, This is Maria Santos, master weaver from Aklan, Philippines. She represents 6 generations of textile knowledge that I, in my arrogance, called unsophisticated. She has taught me that haute couture's future isn't just in laboratories creating smart fabrics. It's also in villages where grandmothers carry knowledge about creating beauty, durability, and technical excellence using methods that predate our fashion houses by centuries. She continued, "We celebrate innovation in fashion, new materials, new techniques, new technologies. But sometimes, the most innovative thing we can do is recognize that indigenous craftspeople, like Maria, have already solved problems we think we're inventing solutions for. Pina fabric achieves translucency without chemical treatment, luster without artificial coating, strength without synthetic blending, pattern complexity without computer assistance, and beauty without compromising sustainability. That's not primitive craft. That's mastery." Today, Pina fabric from the Philippines is used by major fashion houses worldwide, with master weavers like Maria earning incomes that support not just themselves but entire communities. Isabel's fashion house established a foundation supporting traditional textile arts in developing countries, starting with Philippine Pina weaving. And Isabel keeps a piece of Maria's original competition submission, the one she'd rejected as unsophisticated, framed in her atelier with a note below, to remind me that sophistication isn't always where we expect to find it, and that the greatest innovations in fashion sometimes come from village workshops, where grandmothers' hands hold knowledge that our machines cannot replicate and our education did not teach us to value. The Paris designer who'd mocked Filipino weaving now begins every design lecture with the same story about the day she saw Pina fabric on a Paris runway and realized that her 30 years in haute couture had taught her to recognize technical excellence everywhere, except in the traditional crafts she'd dismissed as primitive, and how a humble Filipino weaver taught her that sometimes the most sophisticated textile in the world looks like something a grandmother makes by hand. Because sophistication isn't about complexity of tools, it's about depth of knowledge, mastery of craft, and respect for tradition that has survived because it achieved excellence generations before fashion houses existed to judge it.